This will be for the Khan Academy exercise, Quiz 2, Logarithms. All right, so here's the equation. They want us to solve for t and express a solution as a logarithm in base 10. All right, so we are solving for t. T is in the exponent on the number 10. Okay, t has nothing to do with the negative 3. The exponent is not applied to the negative 3. So we want to get rid of it. We want to isolate 10 to the 2t at first. The opposite of times negative 3 is divided by negative 3. Okay, you want to do that to both sides of the equal sign. Cancels here, and we're left with 10 to the power of 2t. And two negatives divided equals a positive. So we're left with 28/3. All right, and I'm going to leave some space here because we need to take the log of both sides. You want to remember the log property. If you have log base b of b to the x, if the base of the log matches the base of the argument, okay, this right here is the argument, these cancel and you are just left with the exponent x. So that's what I want to occur right here. So I would be I want to get the 2t just by itself. All right, so since I have a 10 here, I am going to apply log base 10. Okay, and you have to do that to both sides, log base 10. All right, on the left-hand side, like I just showed you, 10 and 10 matches. It cancels, and you're just left with the exponent. And when you have log base 10, you actually don't have to write the 10. You can just write log. And that's going to be the log of 28/3. Finally, solving for t, the opposite of times 2 is divided by 2. The 2's cancel, and this is your answer in the form of log base 10. Okay, you can divide by 2, or you can put a 1/2 out front in front of the log. So type log, parentheses, 28/3, hit tab, close parentheses, and then slash to get a denominator, and type 2. So log of 28/3 divided by 2. All right, and after that, they want to find t to the nearest 10,000th. Okay, that's 3 decimal places. So we're going to have to do this on the calculator and round off. All right, so you want to do the log of 28/3, hit equals, and then divide it by 2, hit equals, and I get 0.485. Okay, after the 5, there was a 0, and if the number after the third decimal is less than 5, of course, you round it down. So we are just left with 0.485. So this answer, this mess right here translates to approximately 0.485. All right, evaluate the logarithm, round to the nearest thousandth. Again, that is 3 decimals. So right here, we're going to apply the change of base rule. Why? Because most calculators cannot do log base 3. Okay, so change of base rule, if you have the log base b of x, that's going to be the log of x divided by the log of b. Okay, the base b goes on the bottom and the argument goes on the top. So just remember base, bottom, base, bottom. Now, as far as these logs are concerned, It does not matter which base you use as long as they match in the numerator and denominator. Okay? You could also say ln of x divided by ln of b. Okay? It's the same thing. It's the same answer. And the point of this is to get this in either log form or natural log form, because most calculators have natural log and standard log, but they don't have log base 3. Okay, so let's apply the change of base rule here. We're going to make it a fraction. So we said the base b goes on the bottom. So log of 3 is on the bottom, and the argument goes in the numerator. So log of 346 goes in the numerator. All right, so just remember, base, bottom, arguments on the top, and you can either use log or natural log as long as it matches top and bottom. Okay, so I'm going to do this on the calculator and then round off. All right, so make sure you do log of 346 divided by log of 3. And I get 5.3216. They said 3 decimal nearest thousandth. So you look at the fourth one. If it's 5 or more, you round it up. 5.322. All right, so this was just change of base rule plus calculator work. 5.322. All right, which of the following is equivalent here? And they have a bunch of answers. Basically, you want to apply change of base rule to the top and the bottom. This way, you can translate this and this into the same base. All right, so let's see if I can fit this here. We need a fraction over a fraction. We have a fraction on top and then a fraction on the bottom. All right, so for the numerator, log base 5 of m, we said the base goes on the bottom. So log of 5 goes on the bottom. And log of m goes in the numerator. All right, and same with the denominator here. Log of base goes on the bottom. So log of 15 goes on the bottom. And log of m goes in the numerator. So we have a fraction divided by a fraction. How do we do that? Keep, change, flip. All right, we keep the numerator. So log m over log 5. We change division to multiplication, and we flip the denominator. So it's going to be log 15 over log m. All right, these are multiplied fractions, so we can cancel top and bottom. Log m over log m cancels. And we basically have log of 15 over the log of 5. Now, unfortunately, this is not one of the answers, but what we can do, we can change it back. We can use change of base rule in reverse. All right. So let's see if we rewrite this here as log. What is the base of this log? Well, we said before when we did change of base, the base is on the bottom. So the log of 5, the number on the bottom, is actually going to be the base. And the 15, the log of 15, we said the argument in the numerator stays in the numerator. So the 15 is going to be the argument. All right, so basically we use change of base rule in reverse. If you can't see it, imagine taking this and doing the change of base rule and getting this. Log of 5, the base goes on the bottom. the argument 15 goes on the top. See, this right here is on the bottom, and the 15 is on the top. So we just did the change of base rule, but we did it in reverse. Answer D. All right, the relationship between time t and hours after the dilution begins, and the concentration of salt S of t in grams per liter is modeled by the function. How many hours will it take for the concentration of salt to decrease to 100 grams per liter? Okay, so they said S of t is the concentration of salt, and they said t is in hours. All right, and we're looking for how many hours for the salt to get to 100. All right, so S of t is the salt, and of course, t is the time in hours. All right, they want us to find the time t when the salt is 100. So in place of the salt, S of t, I'm going to plug in 100 and just rewrite the rest of the equation. 600 times E to the negative 0.3 T. All right, and now it's just like a previous problem. All right, we're looking to isolate T. We're looking to solve for T. The T is in the exponent, but not on the 600. So we want to get rid of 600. The opposite of times 600 is divided by 600. Okay, on the right-hand side, it cancels. On the left, you can keep it or you can reduce it. It doesn't matter. Okay, so 100 over 600 is the same as 1/6. And that equals E to the negative 0.3 T. Now, just like before, we're using the log cancellation property. You want to remember, I'll do it the regular way at first, and then I'll show you. Since the base on this number here, on this number with the exponent, is base E. So we're going to use log base E. And on the other side, I'm going to use log base E. Okay, remember, if the bases match, it cancels and you're just left with the exponent. So that's what we want. Log base E and E cancel, and we're just left with the exponent. Okay, so negative 0.3 T. And that equals log base E of 1/6. If you recall, log base E is actually the natural log. All right. I mean, there's nothing wrong with writing it this way, but on your calculator, you're going to see ln, natural log. So I'll write natural log of 1/6. All right, that's your argument right there, 1/6. This is not multiplied. This is natural log of 1/6. Finally, solving for t, the opposite of times negative 0.3 is divided by negative 0.3. Cancels here. Okay, and I'm going to do this on the calculator and round off. All right, so do natural log of 1 divided by 6, hit equals, and then divided by negative 0.3. I did that on the calculator and rounded off to 3 decimals, and I get 5.973. All right, they said nearest hundredth, so it's actually just 5.97. All right, last one. Here's the equation. What's the solution? Round to the nearest thousandth. We're solving for W. Nearest thousandth is 3 decimal places. Solve for W. All right, let's see here. So we're looking to isolate the exponent and solve for W. Right here. The exponent is applied to the 5. It is not applied to the 3, so we want to get rid of 3. The opposite of times 3 is divided by 3. It cancels, and we're left with 5. to the 0.2w. And you can leave it as is, but I'm pretty sure I can do 72 divided by 3, and that's 24. So this is actually 240. If you left it alone, it wouldn't matter. All right, and once again, we are using the log cancellation property. We have an exponent we want to obtain by itself, and we have a base 5, so we're going to use log base 5. All right, whatever you do to one side of the equal sign, you do it to the other. Base 5, that's gone. We're left with 0.2w. And right here, I'm going to use change of base rule. All right, so remember, the base b, this is the base, that goes on the bottom. So log of 5 goes on the bottom. And the 240 goes on the top, log of 240. All right, finally, last step, solving for w. W is times 0.2. The opposite is going to be divided by 0.2. So I'm going to take this entire fraction, and after I solve for it, I'm going to divide by 0.2 for the last step. Let me do this on the calculator, hit equals, and then divide it by 0.2. All right, on my calculator, I'll do log of 240 divided by log of 5. Hit equals, divided by 0.2. Hit equals, and rounding off, 17.027. 17.027. All right, make sure you practice entering stuff like this in the calculator. 17.027.